So very often you have a data set where you have multiple observations per unit of observation. So the unit of observation might be a country, might be a household, might be an individual, and you're observing that individual over time, or that household over time, or that country over time. So you have multiple observations for each unit. And you might have many units, of course. You have many countries, and each country you're observing in each year, or you have many households, and each household you're observing in each year. So you have a panel data set. And very often you want to collapse that panel data set and ask questions about what was the average level of some variable for the country, or the average level for a household, or you might want to know what the average level of the variable was for the entire sample. And so you want to collapse the data set from a panel to a single unit of observation observed per year. So if it's the entire group of countries, what's their average behavior for each year and how that changes over time. Of course, sometimes you want that average, but you want it to be a weighted average. If you have a group of countries and the countries have very different populations, one country like Nigeria, for example, has 150 million people in it, roughly. Another country like Senegal might have only 5 million people in it. And so the GDP, the average GDP of taking the GDP of Senegal and adding it to the GDP of Nigeria and dividing by 2 is maybe not a good representation of the overall GDP, average GDP, because Nigeria has 30 times the population that Senegal might have. I'm just making up those population numbers, they might be off. So you see, sometimes we want to compute an average across the units of observation. Sometimes we want the average to be a weighted average. So I just want to show you how to calculate a weighted average. And we'll do that in this script. And what we're going to do is simulate a data set of countries over years. And we're going to have enrollment rates and population changing in these countries over years. And we'll want to see what the trend is of enrollment over time. We could just take the mean of enrollment rates in every year, but it would be even better to calculate a weighted average where the countries with large populations are weighted more than the countries with small populations. So we have a script here, and I'm not going to talk too much about this part of the script. It's going to read in, we're going to load in some packages and clear it, and then we're going to simulate some data that is a panel of enrollment rates and population rates over a number of years. So here's the data frame that gets created, and we see that we have the ID for the country, we have the year, we have the population of the country in that year, and we have the enrollment rate, 22%, 26%, 29% for that year. And if you look back in the simulation, you'll see that there are 50 countries and 30 years. So we have 1,500 observations in this data set. So you can go ahead and run that simulation if you have the script, if you're in the class. We want to focus here on this collapse part, what we do when we collapse the data set. So we're going to create a new data set. We're going to take the data frame. We're going to group it by year, and then we're going to summarize by year to get a total population. So we'll call pop_all the population of all the countries, of all 50 countries, their total population in each year. So if we do this, right, we should have a data set with 30 observations, and that's what we have, and the total population for all the countries for each one of the years. So population overall goes from 2,600 to 2,672. So it goes up, right, by about 3% over the course of the 30 years that we have here. So that we create that first as a data set, and then we're going to merge that data set back to the data frame of the individual countries. So the data frame of the individual countries in years is 1,500 observations. So we're going to merge this set of 30-year data by year back to that, and that will give us then, if we do just the first step of that, we see that we'll have DF1, which will be 1,500 observations. Now it has 5 variables, so it has one more than the original, and we see that the 5th variable is the population for the total continent, and that of course varies by year, so we see it going up, but it'll be the same for every country because the total set of countries is going to be the same for each individual country. So what we can do then is create a new variable called the country's proportion of population. So divide the country's population by the total population for that year. So if we run that, we'll see now we have DF1. Now we have the population proportion for that year, 0.03. So they had 3%, then they had 3.37%, then 3.33. So their population is declining as a percent. This ID1 is declining as a percent of the total population. So that what we can do then is, I'll come back to what we have here as the alternative. What we can do then is take the data frame 1 that we've just created, group by year, and then create new variables, which is the weighted enrollment, where we multiply the enrollment rate times the population proportion, and then add that up. So we're going to add the weighted value up, weight enrollment, or we can just calculate the simple mean. So we'll just run and do that. So now we have the collapsed data set is 30 years, where we have the unweighted enrollment and the weighted enrollment. The unweighted is just the average of all the countries. The weighted is where we are weighting them by their proportion in the population. And we can do a ggplot to see what those look like. And we see that they indeed look a little different. The red is the unweighted and the blue is the weighted. And the way this data set was set up in the simulation is that countries with larger populations grew faster, their enrollment rates grew faster. So when we weight by the population, we see indeed we get an overall faster change, a larger change in the enrollment rate. I mentioned this alternative way because these two steps of collapsing and then merging and then calculating the proportion, we can do that all in one step, and I'll leave it to you to figure out how this one step works.